So we are going to use the abundance of isotopes of an element to calculate the relative atomic masses, to calculate the relative atomic mass of that element. Follow me, let me show you how to use abundance of isotopes of an element to calculate the relative atomic mass of that element. Follow me, let's go there. It's not difficult. All right, we have example 1. Example 1 says there are two isotopes of chlorine with mass numbers 35 and 37 respectively. If the isotopes exist in the ratio of 3:1, the lighter isotope, the lighter one is 35 because 35 is lighter than what? 37. All right, they said the lighter isotope being more abundant, what is the relative atomic mass of chlorine? All right, if the lighter isotope being more abundant, that means that it will take what? The larger ratio. Is it clear? If they say this one being less abundant, it will take what? The smaller ratio. That's just the meaning. All right, so we have solution like this. We are talking about what? Chlorine. All right, they said this one with mass numbers this and that. All right, so the smaller one will take this and this bigger one will take what? This one. So how do we do that? First of all, you multiply these masses by their what? Their respective what? Ratios. So what we have here, we have 35. 35, they said it is a smaller one, it has the more abundance, which is what? You have 5 like this, you have 3 like this. When 3 multiplies 35, what are you going to have? You have 105. Can you see that? All right, next one we have is this. We have 37. 37 will have the other ratio, which is 1. You now say this times this will give us what? It will give us 37. Can you see that? All right, so that is how this can be solved. Okay, look at the ratio. You have ratio to be what? 3:1. So you come here and find the total ratio. So I will say total ratio is equals to, I have 3 plus what? 1. I will add the ratio together. That will give me the total ratio. All right, 3 plus 1 will give me what? 4. Can you see that? All right, for me to find the relative atomic mass of this element that we are talking about, which is chlorine, I will use the total ratio to divide the total of what we have here. All right, so what we have here, we have relative atomic mass, relative atomic mass of chlorine, we have it like this. Chlorine is equal to, so I'll add this thing together, the sum will give me this. Can you see that? All right, that is the product of mass and what? The ratio. Look at the ratio of this one is 3. Mass is 35. I multiplied, I got this one. Product of this and this, I multiplied and got this one. Then I will get the sum. Then I will divide everything by the total ratio. Can you see that? All right, so I will say 105 plus 35. It will give me what? It will give me 142. Can you see that? It will give me 142. Can you see that? All right, so what do we do? 2 can divide. When 2 divides this, it will give me 2. Dividing this, it will give me 7. Dividing this, it will give me what? 1. Can you see that? All right, what can divide again? 2 can divide this, you have 1. When 2 divides 7, it will give me what? It will give me 3. Remember what? 1. I will carry the 1 and put here. Can you see that? When you put 1 in front of 1, it will become 11. When 2 divides 11, it will give me 5. Remember what? 1. That one, I will put 0 at the back of it. It will become 10. When 2 divides it, it will give me 5 like this. Can you see that? That means that the relative atomic mass of chlorine will give me what? It will give me 35.5. Can you see how this thing can be what? Calculated. All right, remember, this is Engineer Kenneth tutorial. follow this page and share this video so that it will get to the right students that need to acquire this mathematical knowledge. Bye.